everyone, and welcome to lesson 12.1, day 1. Today we're going to talk about finding the probability of simple events. The term probability of an event, and we represent that with a big P and then what event we're talking about, is defined as how likely or unlikely an event can occur. And an event specifically is a set of outcomes, and an outcome is the result of an experiment. So what we use to calculate the probability is we take the favorable outcomes over the total event. So thinking about like the event that we're asking for, like what the times it will be successful over the total amount of outcomes. So if we look at the spinner to the right, if we spin this spinner, what is the probability that it will land on A for the first one? We'll notice this is kind of divided into a quarter, and then C is taking up a whole half of the spinner. So the probability that we land on A is that that's 1/4 of that circle. So that would be it being successful. C is taking up half of our circle. So there's 1/2 of a chance we land on C. And B is taking up 1/4 of it. So that means if we want to have not B, would be either C or A, which are a total of 3/4 of that spinner. So that would be the probability there. Now, we like to represent probability as a fraction. Reminder, officially, this could also be represented as a decimal. So we'd have like 0.25, 0.5, 0.75 would be the decimal version. We're going to stick to fractions for today's events. Now, in an example B, we have a 6-sided dice or a normal 6-sided dice, and we want the probability that we would roll each of these outcomes. So on our dice, we have 1, 2, 3, 4, and 5, and 6. So an even number would be when we have 2, 4, or 6, aka 3 out of our 6 possible outcomes. We always like to reduce our fractions if possible, so that would be 1/2. The probability that we then roll a 2 is just 1 out of the 6 occurrences. And then for number 3, the event that we roll a prime number, hint 1 is not a prime number, would be then if we roll 2, 3, or 5, because 4 has multiples 2 and 2, 6 has multiples of 2 and 3, so those are not prime. Again, we're not including 1, so again, that would be 3 out of our 6 options, or 1/2. Down below, probability of an odd number, then it would be when we have 1, 3, or 5. So again, 3 out of 6 is 1/2. The probability that we roll a 7 is 0 out of 6, because we only go up to the number 6. And then our last one, the probability that we roll a number of not 3. Anytime we use the word not, we call that the complement. Well, 1 out of the 6 options is the number 3. So that means the other 5 out of 6 are not that. And again, to find the complement, think about what is the probability that it is going to work. You do 1 minus that. So again, we do 1 minus the 1/6 to get the 5/6. On the next page, there are some for you to try. What is the probability if you are using the word mathematics, which has a total of 11 letters, that you will get the letter K as a poll, that you will get the letters M, A, or T, that you will get a vowel, so A, E, I, O, or U, and that you get a constant. All right, down in example C, we are upping the amount of dice we are using to 2 dice, and we want to think about the outcomes. If we added these dice together, what would the total number be? Would it be odd? Would it be even? Would it be a specific number? What would we get? Well, reminder when we are rolling these combinations. So dice 1 is green, dice 2 is red. When we roll these combinations, the sum, we kind of start with a minimum of just 2. You can't ever roll a 1 if you're rolling 1 dice, because the minimum number added together would be a 2. We see this sum chart down here. And then we have, the probability of rolling a 3, when that would happen 4. We end up seeing 7 is the most common way to get combinations. And then 8, 9, 10, 11, and 12, kind of like 2. There's only one time that that's going to happen. So if we look here, what is the probability of rolling an even number? Well, half of our 36 total options are going to be an even number, right? Because we're either rolling an odd or an even. So notice it's even every other outcome. on these would end up being even possibilities, right? 8, 6, 4, we get the idea. So again, 1/2 of those would be that probability. The probability that we roll a 5 would be coming from this column, or excuse me, this diagonal right here, right? The combination of 1 and 4, 2 and 3. So that is 4 out of our 36 options, which both of those are divisible by 4, so we could do 1/9. Right? We also can have our calculator help us out with that. Math, enter, to reduce that fraction fourths or second PRB on a non-graphing calculator. The possibility that we roll a 1, as we kind of discussed before, the minimum that we can actually roll is 2, since we'd have 1 and 1. So this is 0 out of 36 options will give us a value of 1. 3 or 8 occur here or over here, right? Oops, that's 9. We would have an 8. So again, using this chart here, we see this is a total, or you could use this one as well. We have a total here of 7 potential ones that give us a sum of 3 or 8. So 7 out of 36. And then our last one is not 7. So 7 is 1, 2, 3, 4, 5, 6 of these are 7. So think about 1 minus the 6 out of 36 that are going to result in a 7 would give us 30 out of 36 that would be a not 7. So that reduces to be 5 out of 6 would give us a value of not 7. All right, now probability of independent and dependent events. Independent events are if and only if the outcome is not affected by the probability of the first or second. They're not dependent on each other. Dependence is when the first event will end up affecting the second event. So if we have a bag of marbles with 1 green, 1 red, or 4 red, 2 yellow, and 3 black marbles, aka 10 total marbles, we want to figure out what is the probability that each will occur if we put the marble back in the bag before we select the second one. So if I want 1 red marble, that is 4 out of my 10 marbles. And if I then put it back in the bag, the probability on my second draw that I would get a yellow is 2 out of 10. So I would multiply those two together. I get 8 out of 100. Or if we reduce that, both of those are divisible by 4, 2 out of 25. Again, we could also use our calculator, math, enter, to reduce that one. What about black then black? Well, we have 3 black marbles out of 10. Put it back in the bag. There's still a possibility of grabbing 3 out of those 10 marbles. Again, you could also type this in your calculator. 3 out of 10 times 3 tenths. And again, put that into a fraction, math, enter, or second PRB. We would have a chance of 9 out of 100. And then our last one, what about grabbing a red, then a black? Well, we have 4 red marbles out of 10. And then again, black was 3 out of 10. So 12 out of 100, which reduces to 3 out of 25. Now that is going to be a slightly different outcome than what happens if we do not replace it, right? We keep the marble out of the bag before we select a second one. So again, we still have a total of 10 marbles to start. So if I'm starting with trying to find red, my probability that I pull a red is 4 out of the 10, right? But if I don't put that marble back in the bag, now there are only 9. So instead of being 2 out of 10, since I already took out that red marble, there's only 2 out of 9 chance of grabbing a yellow. So this time when we multiply, we get 8 out of 90, which in this case, both of those are divisible by 4. 2, we can reduce to be 4 out of 45. The second one, if I'm starting and I want a black marble, all right, again, I have 3 out of 10 potentially. Well, if I keep that first black marble out, I only have 2 black marbles out of 9 total marbles that I could potentially pull on that one. So this one's 6 out of 90, both divisible by 6. So 1 out of 15 would be our reduced fraction there. And again, you can always just type these in the calculators, 3/10 times 2/9, and then math enter is another way each time if you're not doing it mentally. All right, last but not least, if we are pulling 4 red first, our probability of a red first, that's 4 out of the 10. Again, we only have 9 marbles left, and then to pull a black, there still are 3 left to potentially pull there. So 12 over 90 on this one reduces to be 2 over 15. All right, the last example is for you to try. We have 3 boys and 2 girls who are volunteering to represent their class at a school assembly. The teacher selects one name and then another from a hat. Find the probability of each event happening if we're not going to put the name back in the hat out of our total 5 that we originally had. So probability that they are both boys, that there is one boy and one girl, and then that they are both girls. Thanks everyone for watching. We'll work more with these in class.